All right, so let's look at our final problem in the 2018 AP Chemistry Free Response. This is number 7. If you have not done it yet, pause the video, work through these questions. This is a fairly quick problem, and come back and listen to the explanations, and you can look at the point distribution. So for A, we are merely to identify the element based on the PES readout that we have been given. So looking at this PES readout right here, we have 3 peaks. Remember, every peak represents an energy level and an orbital, like 1s, 2s, 2p. And we want to pay attention to the scale of it. The greatest binding energy is over here on the left. The weakest binding energy is over here on the right. So this is going to be the electrons closest to the nucleus. This last one will be the electrons farthest away from the nucleus. And remember, the height of each peak is representative of the relative number of electrons. We know the closest electrons to the nucleus are the 1s. So here we have 1s and 2s and 2p. We know the 1s and 2s have 2 electrons each. The 2p apparently has 3. This is 1 1/3 times taller than these two. So we have 7 total electrons, and that means that our answer is nitrogen. And it was worth 1 point for identifying nitrogen as this element. A radioactive isotope decays with a half-life of 10 minutes. We are asked to calculate the value of the rate constant K. And we were told to include units in our answer. So now for this, we can go to our equation sheet. And in our equation sheet, the only half-life specifically that shows up, although you can use the other integrated rate laws to find half-life as long as you use them correctly, is right here that the half-life of a first-order reactant decomposition, or first-order decomp, is 0.693 over K. And so our assumption is this is a first-order decomp. So we have this equation right here, and we just swap K in 1/2 to solve for the K. In the problem, we were told that the half-life is 10 minutes, and it's 10 with a decimal, so only 2 decimal places. So we divide and get 0.0693, but because of the 2 decimal places, we just leave it 0.069. Now for the unit, 0.693 has no unit, but that was minutes, and minutes is in the denominator, so minute to the -1 is our unit. It was 1 point for 0.069 and 1 point for the correct unit. Another way to remember that is this was first order. It had to be for us to be able to use this equation. First order half-lives are constant. They do not speed up. They do not slow down. So the trick, remember, for the unit of the rate constant K, you will always have time to the -1. Whatever the time unit is, it will always be in the denominator. The molarity will be the negative of the overall order, which here had to be 1, minus 1, which means we get 0, which means all we end up with is time to the -1. So, to finish, if 64 atoms of this isotope are originally present in a sample, what is the expected amount of time that will pass until only 1 atom of the isotope remains? And we are specifically told to show how you arrived at your answer, because a lot of students try to do something like this in their heads. So we have 64, and we have 10-minute half-lives. So remember how we looked at doing this in class. Start with your original amount, and every arrow is a half-life. So after 1 half-life, 32. After a second half-life, 16. 8, 4, 2, 1. And so this is 1, 2, 3, 4, 5, 6 half-lives. And because each half-life is 10 minutes, that means 60 minutes. And because the 10 with a decimal was 2 decimal places, 2 sig figs, that's how we would report our answer. The other way is with the integrated rate law for a first order reactant, which we know this is. This is a version of the equation found on our AP Chemistry equation sheet. If we rearrange to solve for the time, well, we know that the original value was 64 atoms. We know that we end after the elapsed time with 1, and we would be dividing by our negative k. And you also get 60 minutes for an answer right there. We again would have to have only 2 significant figures, and this was 1 point, ending this 4-point problem.